Welcome to EP3, where Energy Plus is unleashed. This is part 5 in a video tutorial series where we're taking you through start to finish, creating an energy simulation of an educational building located in Singapore. In this episode, we will assign HVAC systems to zones. We're going to run the first model, and we'll do our initial ETTV and RTTV analysis. So starting off where we left off in tutorial 4, we have our building defined, we have our spaces defined, we have added some detail to our elevations, and we have our internal loads defined. So now we need to take a look at our HVAC systems. So we'll go to our HVAC viewer, which we get to by clicking this button up here. And what we're seeing are HVAC systems that were created during the wizard phase of our first tutorial. We added a direct outdoor air system and a fan coil. So there's a lot of stuff going on here, and I'd like to take you through it piece by piece. So on the left, we have the outliner. And if you're familiar with eQuest or Energy Plus or most simulation engines, they deal with loops. So this is a concept that you have a supply and a return and some conservation of mass in your building with regards to air flows and water flows. So we have an outliner which is organized by loop, and there are a bunch of different loops in this HVAC system. The first is called DOAS, and DOAS stands for Direct Outdoor Air System. If we zoom in, we can see that we have these sort of duct-like looking connectors on this DOAS, and this is an air loop. We also have a hot water loop, a chilled water loop, a condenser water loop, and a service hot water system loop. Now, this building is located in Singapore. It does not have a heating system. However, some object types, such as our fan coil, have a heating coil, a hot water heating coil that require all of the infrastructure associated with a hot water loop, even if it never actually gets used. So that's a little bit of a pain, and we can also explore a couple different system types that do not require the heating loop infrastructure. So if we look at, say, the chilled water loop, we have what are called set point managers, and these define the conditions at particular points or nodes in the loop. So here we have a set point manager that is setting the desired conditions at the outlet of the loop here and at the outlet of the chiller. We also have the supply side, and we can look at the individual branches. Branches are Energy Plus loop system architecture, and we just display them to you in EP3. You don't have to do anything with them. You don't even really have to understand them all that much, but we show you where they are. So we have an inlet branch, we have a bypass branch, and then we have a chiller branch. And you can see where each object is and how it's connected. On the demand side, we have, again, an inlet branch. We have a branch for our cooling coil. We have a bypass branch, and we have a branch for our fan coil, cooling coil. We also have a condenser water loop and a service water heating loop and some other things. But let's take a look at our actual zone HVAC equipment. So I'll open my selected object dialog, and I can click on my fan coil. So I can click on it here, or I could click on it in the object space if I want to. So this object there's a 4-pipe fan coil, and it has some sub-objects as well. So it has an outdoor air mixer, so the fan coil can provide outdoor air, outdoor ventilation air to each zone. It has a fan, it has a cooling coil, and it has a heating coil. So let's actually zoom into this object a little bit. All of these objects in Energy Plus are connected via nodes, and we show you where those nodes are. And if you mouse over them, it will just show you where these nodes are in the diagram. We give them a kind of plain language name so you can easily find it later, but we don't actually allow you to edit any of these. So these are all of your node locations. The cooling coil has a water inlet and outlet node, as well as an air inlet and outlet node, as does the heating coil. Water inlet and outlet node, and then the air inlet and outlet node. So I'm going to make a change to the heating coil. This is a building that's located in Singapore. There is no actual heating system in this building. So I'm going to change the availability schedule for this heating coil to always off. So this will never turn on. Now, the first simulation I want to run is going to be just the zone HVAC fan coil. I don't want to model a direct outdoor air system yet. So when we brought these systems in using the wizard, it actually created efficiency measures for me that for each HVAC system I imported. So if we look at the fan coil HVAC system, we can see that that direct outdoor air system kind of goes away. So let's assign fan coils to our building geometry. So let's take another look at the building geometry. So to get to the building geometry, we click on this button here. It's also how you get your building geometry outliner if you had closed that. So right now we have our building geometry and we have our HVAC systems, and they're separate. They're not connected just yet. To connect them, I'm going to open my HVAC assignment dialog. This is how we connect our HVAC systems to the building geometry. So we can assign HVAC systems by template or by zone. So this is a relatively large building. There are a lot of different zones. It's much, much faster to assign HVAC systems by template because there's, let me see, maybe 8 different templates instead of 100 and some odd 200 zones. So each zone or each template is going to get the same fan coil. And if I look at assign HVAC system by zone, I can now see that all of these zones are inheriting the state of this template. If I click on the zone and look at, if I click on the zone HVAC object and look at it in my window here, I will notice that I have something new. So I have something called replicated objects for zone HVAC for pipe fan coil. And if I open this, this gives me a list of every single zone to which the fan coil has been assigned. And I can adjust some of these parameters either by zone or by the entire fan coil. For now, I'm going to leave all of the defaults. One thing to notice here is that the supply air fan operating mode schedule name is inherited. So here we have university lab operation for this lab zone. So these schedule values are being picked up from those zone and space templates that we set up last time. So now that I have HVAC systems assigned, I'm actually ready to run my first simulation. And I'd like to run the simulation just for sizing periods instead of for the entire year, because this is a large building and it's going to take a little while to simulate. So I will make that change in the global model, not in the fan coil model. I want this change to be reflected everywhere in the model at this point in time. So I'll go to simulation control, and we're going to change run simulation for weather file run periods from yes to no. I also need to select the weather file that I want to run this simulation with. So I'm going to go up to my model settings, and if you go to, so up here there's some general settings, and If I go down a little bit, I have some model settings. And I have a current weather file, which is blank at the moment. So I can click Change Weather File. Before we do that, we may want to download a weather file. So if I download the weather file, this will take me to the Energy Plus website where all of the official Energy Plus weather files are stored. There are also some other resources where you can get Energy Plus weather files. So Energy Plus weather files are an EPW format. So we know we're looking for a Singapore weather file. So I can just keyword search for Singapore and hit search. Okay, so it's going to bring me to this weather file, and I can download either just the EPW file, which is what we need for this simulation, but you may want to download some of these other files, which can be useful for other types of analysis. So I've already downloaded this file, but go ahead and download it, save it somewhere where you can find it in the next step. So now let's change the weather file, and I'm going to select that Singapore weather file. And now I can simulate my first model. So I'm going to hit export. The first time you hit export, it's going to ask you to confirm the outside boundary conditions for certain materials. So it will only ask you this once. And these all look like exterior or outdoor materials or construction. So I'm going to hit OK. So now I can select the fan coil as the efficiency measure that I would like to simulate, and I can hit simulate. So you'll notice that the file name is just an underscore. And if we do not enter any sort of file name, then the default file name will be the name of the efficiency measure. So in this case, fan coil. We could type something in here and have a prefix. So if we typed in, initial run, it would then, the actual file name would be initial run fan coil. But I will just use the underscore as the default and then hit save. And I hit OK to start the export. And this will give you the updates of everything that it's doing to translate the model from EP3 to Energy Plus. And this can take a couple of minutes depending on the size of the model. For a small model, it will happen in a few seconds. And a larger model like this, it might take a minute or so. When it's complete, it will automatically start simulating EP3 or simulating the Energy Plus model. And here it is simulating in the background. And then here, these are some errors and warnings that happen in the translation from EP3 to Energy Plus. So if you have any simulation errors in Energy Plus, a good place to take a look at are these warnings to see if they give any clues as to why you had a simulation error. So now the simulation has completed. It says it completed successfully. The results will automatically open up, and because we did not simulate for any actual weather periods, we're not going to have sort of annual results, but we may have some other summary type of results that pop up. But for now, I'm just interested in verifying that the simulation ran. For every simulation that you run, there'll be a little button up here with the name of the simulation run, and there'll be either an X or a check mark next to it. So a green check mark will tell you that it ran without any severe errors. A yellow check mark will say it ran to completion, but there were some severe errors. And if there's a red X, then there was some sort of issue or fatal error. In most cases, you can click on this box and it will open the AI assistant in sort of error resolution mode. So we can see that it's referencing the error file. So we have some different types of warnings, and I can ask it to give me some details about the severe error. Okay, so it's saying that it is not able to automatically calculate the zone geometry of this one particular zone. So we may need to take a look and verify that that zone is actually fully enclosed. So let's go and take a look at our model. And I've actually just forgotten which zone it is. I think it was floor 101, floor 101 corridor. Floor 101 corridor. Okay, so we can kind of see that zone highlighted in there, but let's turn off some geometry so that we can really get an idea of this particular zone. There we go. Okay, so I can see these walls here, and if I go up, I can see that it's picking up on this surface. That looks more or less correct. Oh, and it's also picking up on a surface here. So we may be missing kind of a roof surface on this corridor. So let's take a look and see. So I think that's what's going on with that particular space, is that we are missing a roof surface there. So let's add that little surface to one of these roofs. We could add it to the ground floor roof. So let's go into ground floor roof, and I'm going to turn off the other roofs. So I'm in ground floor roof, and I'm just going to draw this rectangle. And I want this to be an interior floor / ceiling construction. So I'll go to materials, select interior floor ceiling construction. I'll go to the paint bucket tool, and then I'll paint it. And now this floor should recognize that it is, or this ceiling should recognize that it is part of this zone. But we have this space is recognizing that it's part of this zone. We also have this surface right now is being recognized as part of this zone. So we need to make a couple of corrections. So for the most part, EP3 can do surface adjacencies automatically, but in a couple special cases, and this is a very special case where you have this kind of hanging bridge in the middle of a space, we may need to make some manual adjustments. So I'm going to go to my selected object dialog, and I'll make sure I have my space selected. And I'm going to say edit space surfaces. So you'll notice that the walls are now either gray or they have our normal recognized surface colors. So anything that is included in this particular zone or space will have a colored surface, and anything that is gray is not included in this surface. So I can add a space by clicking on it, and I can remove it by holding the shift key down and then clicking. So I'm just removed this space or this surface from this space. And now I can just hit the space bar and everything kind of goes back to normal. So if I see, may need to reopen the dialog to get my highlighter back. But now I can see when I mouse over the corridor that the corridor spaces seem correct. Let's look at our warnings on our spaces and see what comes up. Okay, so it's flagging these two spaces or these two surfaces as surfaces that are do not have the type of construction that we're looking for. So let's see. So we have this floor 01 corridor surface, and it does not have an adjacent surface. It did not auto detect an adjacent surface for this particular surface. And the same with this other surface, I believe that EP3 was not able to automatically detect a second surface. So we need to assign these surfaces to the space that they belong to. So let's see, I believe they belong to this ground floor lobby that goes up many, many, many floors. So let's take a look at that ground floor entry lobby. Yes, so this ground floor entry lobby surrounds kind of all of this volume. So we need to assign these two surfaces to that ground floor entry lobby. So I can say edit space surfaces, and I just need to select this one, and then press the space bar. And now if I highlight my suspected surfaces, nothing is showing up. So that's much better. So when we re-simulate the model, that error should go away. So most buildings, EP3 can fully detect surface adjacencies automatically. It's only very special cases like this where you might need to go in and do just a little bit of tune-up. So let's re-simulate the model, and we can simulate it for a full year at this point, so we can take a look at some results. So I will go back to my simulation control in the global model and select yes for weather file run periods. I'll save it, and then I'll hit export, fan coil, and simulate. So the simulation completed, and we still have a yellow check mark next to this simulation run. So let's see what Atlas has to say. So there are quite a few errors and warnings, and we can ask Atlas to summarize the critical ones for us. So we still have two zones where we have the automatic volume calculation is not working. And at this point, we've done our best to assign all of the surfaces to these zones, and we can take another look, but I would be tempted to just manually set a volume for these two zones. It's also giving us some other notable warnings. So some of our zones, all of our zones use flow per exterior surface area to calculate infiltration. And these, a number of zones do not have any exterior surfaces, so they won't have any infiltration. And that's actually appropriate, so that's fine. We also don't have any heating load, which we're expecting because this is Singapore. It's a cooling dominated climate. There's actually no heating system in the actual building. And then there's some cooling design calculations that we may need to take a look at because their Energy Plus auto-corrected the design conditions to align with the design leaving air condition and temperature. So it's given us some actions, and if we ask it to, it can help us fix or change the EP3 file to fix these issues. So the main two is to take note that it's floor 101 corridor zone and ground floor 12 entry lobby zone. Those are the two where I want to manually set a volume. So let's take a look. So this entry lobby space here, and most of it is this full story space. So let's click into the ground floor, and we can measure this space area. I can actually use a trick here. So all of the zone drawing that I've done in the past, I've done with the pencil tool highlighted. This means that any shape that I draw, any enclosed shape that I draw, will be recognized as an EP3 space. What I would like to do is I would like to subdivide this surface so I can get the area of this portion and the area of this portion separately. So I can toggle into drawing building geometry. So now if I draw a line from here to here, it's just going to give me an edge. It's not going to give me a space boundary. So now I'm going to look in the SketchUp default tray and underneath entity information. So if you don't see that, you may need to expand the entity information. I can see that this surface is 150 meters squared, and this surface is 25 meters squared. So I can erase this edge now. I don't need it anymore. So let's create an Excel sheet to just do these calculations for us. Okay, so we have our single story. So this is area and height. So this is 25 meters squared, and the multi-story was 150 square meters. So the single story height is, so I use T to get the tape measure, and I'm just going to measure this height here. So that's 4 meters. And the multi-story height is 25.5 meters. So we can do 4 meters, 25.5, and I'll multiply them. And I can add them up. So we have a volume of 3,925 cubic meters for that particular space. So I can go to my selected object dialog and click on entry lobby. And actually we need to assign this volume to the zone, not to the space. So we will go to our zone. We haven't worked with zones so much yet, but in EP3, every time you create a space, a zone is automatically created for that space, and there's one space per zone. If you want to get into more detailed modeling, you can have multiple spaces assigned to the same zone. So let's find that ground floor lobby zone. And I'm going to make this change in the global model. It applies to everything, not just the fan coil alternative. And we will type in the volume instead of auto-calculate, 3925. And in the ceiling height, we could actually type in 25.5. So the next zone that we need to calculate was floor 101 corridor. So I will take the surface area of these two floors, which is 26.12, and we'll multiply that by the height here. So actually, in this case, we could go to the floor 101 corridor and enter 26.12 into the floor area, and what was it, 3.5? And then we just need to multiply those two to get our volume. So calculator, 3.5 times 26.12, so 91.42. Unfortunately, it won't simply multiply the ceiling height and the floor area to give you the volume, so we need to do that manually. So now we can re-simulate the fan coil model and take a look at our results and start moving forward with the analysis. Okay, so we have a successful simulation with no severe or fatal errors, and we can start taking a look at results. This is the standard yearly energy use summary. And when you run multiple efficiency measures, we can start to get some comparisons. But the first thing that I'd like to do is do an ETTV calculation. And to do that, you go to this View Building Data tab. And here we can get data for all sorts of different all those different data points. So anything related to a surface or a space or a zone, we can get data related to any of those objects and then display it in 3D on the model over time. We actually need to switch to the efficiency measure that we simulated. And then we'll see next to ETTV and RTTV data we can calculate. And we'll select our location, which is Singapore. There's actually just one option in EP3 at the moment. So it's taken a moment to calculate, and then it will display our ETTV and RTTV data. So there's a scale here. So green represents surfaces that do not have a large contribution to the ETTV or RTTV value. And as you go up into the yellow, orange, and red, the surfaces have a larger contribution. So you can get a visual representation of which surfaces have a larger impact on these data points. Now, before we continue, I'd like to go back and take a look at the site plan image because we actually don't have this building oriented correctly at this moment in time. So this is the site plan, and we'll notice that in our building, green is the north axis, and the building is not oriented correctly according to the site plan. So we need to rotate the building about 110 degrees. So I'll open my selected object dialog, and if I click on building, I can type in 110 degrees, and the building will rotate. So we can rerun the simulation and do the ETTV calculation. Now the ETTV calculation needs to be done on an efficiency measure that has simulated, but it does not have to simulate for an entire year. So we can run the simulation just for the without running it for the weather file period in order to look at some of the ETTV options. So I can hit no, and we can run the fan coil simulation again. Okay, so this simulation has completed, and because we did not run it for a full year, we're not seeing the energy totals, but we can rerun the ETTV and RTTV calculations. And you may notice that the ETTV is a little bit higher with the building in this orientation. So we could run an efficiency measure and kind of store the original orientation as an alternative. And we can also see that these windows here, especially as you get kind of away from areas where they may have been receiving a little bit of shading, that some of these windows are a bit darker orange color, which means that they have a larger component of the ETTV total. So this ETTV is actually pretty good. I think the green mark baseline needs to be lower than an ETTV of 45. The main reason for this ETTV being so good is that the window material performance is actually quite good. So we have a solar heat gain coefficient of about 0.23, and that's part of why that ETTV is so good. So now we can start to set up a couple of alternatives so that we can use this to analyze some alternatives for the building. So let's analyze an alternative which is zero building rotation, or we could say east-west axis building. Okay, so now I'll go to my east-west axis building efficiency measure. I will select my building and I'll make the axis 0, and that will position the building on the east-west axis. So this is an alignment with the original measure that we did. So I want this east-west axis building I want to be able to compare it to the fan coil efficiency measure that I ran. So I'm going to change the EEM bases. So here's a list of all of the efficiency measures in the model, and I'll take a look at my east-west axis building, and I can click fan coil as one of the measures that this is based on. The change in ETTV from one axis to another also raises some questions about whether adding some building shading could reduce that ETTV. So let's add some building shading. So to do that, here in my building geometry outliner, I can add site shading and I can add building shading. Site shading would be used for things like large trees, adjacent buildings, things that will shade the building no matter where the building is and how we change the orientation. Whereas building shading will move with the building. So if you change the orientation, the building shading will also move. So let's give an example. We'll go back to the global model. We like to do all of our general work in the global model. So let's add some site shading. So we are now in just a SketchUp group where I can kind of freehand draw some site shading. So if I say, and I'm using P to push pull, so let's say there's an adjacent building here. And if I go back to my east-west axis building, you can see that this adjacent object stays in the same location. So now let's add some building shading. So the building shading, if we could add some angled louvers over the windows on this axis and this axis. So I will draw, maybe it's 1 meter deep louver. And then I'm actually going to angle this. So I'm going to hit Q, which gives me the protractor or the rotation tool. Once I had it in, so when you hit Q, it will snap to any axis. So I want to snap it to the red axis. So when it does, I'm going to hold Shift down, and then I can grab a first point. I don't have to grab Shift anymore. And then I can grab another endpoint and I can rotate it. And if you look in the lower right, it's giving me an angle. So we can do an angle of, say, 30 degrees. And I'd like a bunch of these louvers, so let's copy them down 1.5 meters. And let's do 20x. All right, we got a couple extra. It's actually going underground. And I can erase what's left. If I triple click a face, it will select everything connected to the face. So I'm triple clicking these faces and then deleting them. So I have louvers on this side of the building. I can copy these. So M for move tool, and then control gives me the plus mark. I can grab a reference point. So we'll grab this point here and just align it there with that corner of the building. So now this is way too long, but if I select, so left to right select, will select only what I'm completely surrounding. If I did a right to left select, it would select the faces as well, which I don't want. But left to right select, I can select only those edges. And then if I hit move tool, I can grab an endpoint and just drag it back to the edge of the building. And again, this is a little bit lower, so I'm going to erase these ones that are underground. Okay, so now I want to do the same thing on the other side of the building. So I'm going to take these louvers, move, and I'm just going to put them out in space here for a minute. Now I'm going to, I can actually use this mirror tool up in the SketchUp mirror tool, and if I click the green plane, you can see it just mirrored it about the green plane. So now let's move this back to the edge of the building, and same thing, I'm going to left to right select only those edges. I'm being careful not to select anything on this side. Oh, and I actually moved instead of copied, so let's undo. Okay, move and control key to copy it, move it over, and then the mirror tool, and then I can move this back next to the building, and I just want to select these edges, hit M again. I can select an edge here and drag it all the way down to the end. Now some of these louvers are underground. I can erase the lowest two. And I'd also like to add a few here and some here. So I'm going to do this a little bit faster now. Oh, and I've selected some on the other side. I just want these ones. You can also have multiple building shading objects. You could do one for, say, north louvers and a different one for south louvers. Might make it easier to manage all these components within SketchUp. Okay, so let's do 4x. Okay, and then let's grab a few of these here. And actually need to leave room for that door. And here we go. So we have louvers. And these louvers will show up in all of our efficiency measures at the moment. So I can create another efficiency measure called louvers. And if I select my building shading object, so let's go to our selected object dialog and select our building shading object here. There's a button that says Manage Availability in EEMs. And when you open it up, it will give you a list of all of the efficiency measures in your model. And you can say whether you want this particular object to be in each efficiency measure. So right now it's set on in the global model, and then all of these other ones inherit the status. So they're all inheriting eventually from the global model, so the louvers are going to be on everywhere. I'd like to reverse this, so I'll make it off in the global model, and then the louvers efficiency measure, I will turn them on. So now I can create a, so the fan coil efficiency measure is fan coils with the building in the north-south axis, and the east-west axis building is a fan coil model with the building in the east-west axis. So I'm going to create two more efficiency measures. So I'm going to say north-south axis louvers, and I will also say east-west axis louvers. And if I change EEM bases, I can make the east-west axis building and louvers the base for this efficiency measure. So east-west axis louvers, I will make, north-south axis louvers, we do not want, we wanted to make the base the fan coil and the louvers. So let's do this again. Start from scratch. So change EEM bases, north-south axis louvers. We're going to make the base be the fan coil and louvers. It automatically will inherit this HVAC templates off because it's part of the fan coil efficiency measure. So you can leave the HVAC templates off efficiency measure as part of your efficiency measure chain. You can also change the order in which efficiency measures are applied. So in this case, it won't make a difference whether the louvers are before or after these two. But when you start having inputs that may conflict with each other, being able to change the order that the efficiency measures are applied can be very useful. So east-west axis louvers, I now want to select the east-west axis building. And so that gives us the fan coil and the east-west axis. And then I also want to select the louvers. And we can put them in front if we like. So now we have a whole bunch of models that we're going to simulate, and we can evaluate how each of these options affects the ETTV and also the whole building performance. So I'm going to go back and set the simulation to run for the entire weather period. And I'd also like to set a couple of other building parameters that we can look at. So we can look at perhaps the surface outside face sunlit area. So if we look at that on a monthly basis, that could be useful. A lot of these, you can look at them on an hourly detailed time step level, but monthly or daily is usually as much detail as a human can process. We could also take a look at some zone or space. We could do zone, air system, sensible cooling energy. So again, let's look at that on a monthly basis. Okay. So now we'll simulate east-west axis with louvers, then the fan coil, and the north-south axis with louvers. So we've simulated all four of these alternatives. And now I'd like to update the ETTV and RTTV calculations for each one. So we'll go to open the building geometry outliner. And for each alternative that we haven't yet run these calculations for, I'm going to switch to that efficiency measure and hit view building data, and I can calculate the ETTV and RTTV data. So we've done the ETTV and RTTV calculations for the four different alternatives that we simulated. And we can take a look at those results in the graphical interface where we see the building highlighted and see the surfaces that contribute more highly to the ETTV and RTTV numbers. And we can start to see some patterns, like when the building is on this more of a north-south axis, we see a higher ETTV, and we see that these windows have a little bit more of an orange color instead of the green of the walls. But when louvers are added, that ETTV number goes down and it becomes similar to when the building is at the east-west axis. However, it can be challenging to keep all of these numbers in your head. So also, if we click View Results, so here we have a table of the ETTV and RTTV calculations that we completed, and we can look at the comparison between our different efficiency measures. So we can see that the lowest ETTV is when we have an east-west axis building with louvers. Also, if you remember, we selected some other data points to take a look at. We have our, we selected to track the surface outside face sunlit area and the system zone air system sensible cooling energy. So if we look at surface outside face sunlit area, let's look at this for the north-south axis building without the louver. So that's actually the fan coil efficiency measure. And let's see. Let's look at the surface outside face sunlit area. And we have a couple of date ranges. So June 10th and December 16th. These are the summer and winter design day conditions. And then we have a January through December, and that is our yearly date range. So we want to look at every month from January through December. So I'll click OK. And we have, again, some color coding on our 3D geometry. And we have this dialog box here where we can pull this slider and move and select a particular month. And most of this data is a little bit easier to interpret, and you get better data if you click Normalize by Area. So the scale has now changed, and we have a surface face sunlit area, so that's between 0 and 0.5 meters squared per meter squared. So it's basically between 0 and 51%. So I can pull this slider over and take a look at which faces have the most, are receiving the most sun. So you might take a look at this, and if you wanted to say optimize the cost of the building, you might decide that, hey, on these two sections here and here, they're catching a little bit less sun, so maybe I can save some money by removing some of those louvers. So now we're starting to see how we can use EP3 and this ETTV calculation to compare alternatives. So let's set up another alternative that has a lower grade window. So let's call this baseline glazing. So we could do a solar heat gain coefficient of the baseline glazing at, say, okay, and that we have not yet run a simulation for baseline glazing, so it cannot give us that same output data for baseline glazing. So we're going to change the solar heat gain coefficient. So we'll change the solar heat gain coefficient, and we want to make sure we change it for the glazing type that's actually used in the building. So non-residential fixed fenestration glazing is, I believe, what is used. Non-residential fixed fenestration glazing. Yes, so we're using the fixed fenestration glazing and the entrance door fenestration glazing. So I can actually select both of these and then change this value. and it will ask if I would like to change the value in all selected objects. And that's a strategy that you can use throughout EP3 to change the values of multiple objects at the same time. Let's change that to 0.45. And we also want to select a combination of building orientation and louvers to run this baseline glazing efficiency measure. So we can actually set up a couple of different efficiency measures so we can run them with all of the combinations. So we could say north-south axis baseline glazing and north-south axis baseline glazing with louvers. And then we could do east-west axis baseline glazing and east-west axis baseline glazing with louvers. And now we'll change the EEM bases. So we have quite a few more. North-south axis baseline glazing. So in this baseline glazing efficiency measure, let's also include the fan coil HVAC system, because this is going to be included in all of the other efficiency measures. So now with north-south axis baseline glazing, we can choose the actually, yes, we don't actually have to choose anything else other than baseline glazing as a baseline. Now, north-south axis baseline glazing with louvers. So I can choose now north-south axis baseline glazing as a baseline. And I can choose louvers. East-west axis baseline glazing. So I can choose the east-west axis building, the baseline glazing, and that's it. Okay, and then east-west axis baseline glazing with louvers, I just need to choose this east-west axis baseline glazing, east-west axis baseline glazing, and then I also need to select louvers. So you can see that as I'm selecting a baseline EEM that has other things included, that those all are now automatically included here. If I change some of the included EEMs in this east-west axis baseline glazing efficiency measure, those will not get newly inherited here. So if I choose, say, the DOIS water coils as part of this one, even though this one references this one, DOIS water coils are not added after the fact to everything else. So if you want to see what is included in each of your efficiency measures, take a look at this list and see which blocks are included. So I'm going to remove the DOIS water coils because it's not a fully fleshed out HVAC system efficiency measure. I'm also going to create right now the fan coil efficiency measure is the east-west axis building without louvers. Or I'm sorry, it's the north-south axis building without louvers. So the fan coil nomenclature in this analysis is a little bit confusing. So I'm going to create a new efficiency measure and call it north-south axis building. And we'll just, where are we? North-south axis building. and we'll just apply the fan coil. So those two efficiency measures are going to be the same, but the naming is a little bit easier for us as we're doing this analysis. Now, before I rerun these simulations, we can change the EEM order. So this is the order that the efficiency measures are displayed. So both in this drop-down here and in our results. So we may want to take a look at things kind of in an order. So let's look at our north-south axis building with baseline glazing. We want to look at that first. Then we'll do north-south axis baseline glazing with louvers. Where are we? There we go. North-south axis baseline glazing with louvers. Then we will do east-west axis baseline glazing, east-west axis baseline glazing with louvers. Then we'll do the north-south axis building, north-south axis with louvers, east-west axis building, east-west axis with louvers. Okay, so these are the actual 8 efficiency measures that we are currently analyzing, and the other ones are ones that we're using to build these 8 here. Okay, so I'll run another group of simulations. So if I refresh this dialog, you can see that I now have my efficiency measures all in that order. So you can create these tariffs directly in the wizard, but we didn't do it at the wizard level, so I'll show you how to do it at the detailed level. So for electricity, we want to capture the electricity for the entire facility. So for output meter name, I will type in electricity facility. And if you mouse over, the hint tells you that it's often set to electricity : facility or gas : facility. The conversion choice, we're going to choose kilowatt hours. EP3 and therefore Energy Plus's native units for results are joules. So we want to set our output or our utility rate structure in kilowatt hours. Okay, so now I'm going to create a utility cost charge simple. So with these different utility types or utility cost types, you can create very complex rate structures within EP3 and Energy Plus. But in this case, we're just going to keep it really simple. We're going to do a demand charge and an electricity energy charge. So this first one I will call electricity demand charge. And the tariff is the electricity tariff. The source variable will be total demand. And I recommend that you take a look at these notes and also at the Energy Plus input-output reference if you would like to create more detailed rate structures. So the category is demand charges, and we're going to use a rate that is 15 Singapore dollars per peak kilowatt per month, and we'll also create an electricity energy charge. So tariff name electricity, source variable total energy. The category is going to be energy charges, and it's going to be 20 cents per kilowatt hour for electricity usage. So we have electricity usage and electricity demand. I'm just going to fix my typo here. So now we have our electricity rate completely fleshed out. We also want to create a water tariff. So this will give us an idea of how much we need to spend to run the cooling tower and to provide domestic water. So we'll name it water tariff. And the output meter is water : facility. We'll convert to meters cubed. And here you have the option to add, say, a monthly charge, but we're just going to do a total charge per volume. So we need, again, utility cost charge simple, and we'll call that water energy, well, water usage charge. So we'll select here the water tariff. It's still total energy is going to be the source variable, and energy charges, and then we'll do 4.5 Singapore dollars per cubic meter of water. So I have those rate structures fleshed out, so I'm going to rerun the original simulations plus the new baseline glazing simulations that we set up. And I will then have quite a lot of data to look at to make some decisions about how I want to design this building. Which glazing do I want to use? Which orientation? Do I need louvers? And I can look at that based on the ETTV calculations and performance. I can look at system sizing, and I can also look at operation cost. So I let the simulations run in the background, and now we have all 8 simulations complete. So we have results for all 8 simulations, and we can take a look at it in table format. We also have graph format, so you can see the impact of some of these efficiency measures on energy use. We can also take a look at many, many tables. If you go to select reports to display, this gives you a big long list of the different standard Energy Plus reports that are available to you. With EP3, we've pre-selected some of the most commonly referenced reports, such as the lead summary. And in the lead summary, there is also a cost breakdown. We have both process cost and total energy cost. And you can see that there is some reduction as we go along between the north-south axis, baseline glazing, adding the louvers, changing to east-west, louvers on east-west, and then the better glazing performance also improves our energy efficiency. We can look at ETTV and RTTV calculations in table format, but first we need to rerun those for each simulation. So to do that, I will go to each simulation and run the ETTV and RTTV calculation. Now that the ETTV and RTTV calculations have been updated, we can take a look at them in table format and also in graphical format. And here it's really easy to see that the presence of louvers and changing the glazing type as well as the orientation have a significant impact on the solar gain, therefore the ETTV of this building. Now, we didn't make any changes to the roof at this point in time, so the RTTV stays relatively constant. But this baseline glazing on the north-south axis without any louvers is going to have fairly strong solar gain. Another thing we can look at that will give us some indication of the heating loads is we can take a look at some plant sizing information. So we have a component sizing summary, and we can take a look at our chiller, our pumps. We could take a look at fans, cooling coils, whatever it is that we like. But the pumps and the chiller and the plant loop are the ones that are really going to give us an indication of the differences in peak load between the different efficiency measures. There's a ton of data here, and I encourage you to take a look at the Energy Plus documentation and start to dive into the data that's available to you through EP3 and Energy Plus. So I'll hit update. And then I have this component sizing summary tab. And this is the sizing for the main chiller. So we'll see this is a similar pattern as with the ETTV calculation, although it's a little bit less dramatic. That as we move through these efficiency measures, we have a trend towards a smaller central chiller. This can be a good thing to present to your client in that sometimes adding shading or improving glazing can result in some upfront first cost savings when you can downsize your central plant. So this is the flow rate here and the capacity in watts. We also have a condenser flow rate. We can take a look at our pumps. So we have different sizes for different pumps. Again, the hot water supply pump is next to nothing because there's no hot water load. And we have also plant loop sizing. Let's take a look at our north-south axis baseline glazing. And right now we have the data visualization for ETTV and RTTV displayed, but we can change that to something else. So if you remember a little ways back, we decided to report on the surface outside face sunlit area and also on the zone air system sensible cooling energy. And we decided to report on those variables on a monthly basis. So we can take a look at the zone air system sensible cooling energy. And I'm going to select a time range. So I have 3. So this June time range, this is our summer design day condition, this is our winter design day condition, and then this is our year. So we have January through December for our year. So I'll take our year. And in this case, we have the units are in joules, and this is per zone. So it's a zone system sensible cooling energy. I'd like to normalize by area, and that's going to give us a little bit better idea about which zones are kind of the hot spots as far as cooling per floor area. So we can see that zones that have a lot of glazing, so particularly this multi-story space is a hot spot, and that's partly because it has a lot of glazing per surface area and it's very tall. It also has a roof. We can see that the spaces on the top floor have a higher cooling per floor area. There may also be something going on with space type. This may be a stairway that does not have a cooling system. So this would not have, yes, I think these are stairs. So let's take a look. on the ground floor. Let's close this for a moment. Yes, so this whole corner of the building, and actually if we look at our space template for stairs, it should highlight that for us. Yes, so our stair type is going to have no cooling load because it's not a conditioned space. Looking at data this way, it can be a very good way to have an idea about which particular spaces or conditioning types you might want to look at to target some efficiency measures. We can also look at our surface outside face sunlit area. And again, we'll take it on a yearly basis and normalize by area. And we didn't, on the other one, we didn't take a look at the different months, but here we can drag through and take a look at the different months. So we can see a pattern in this edge of the building where some of these spaces or some of these surfaces actually get less sunlight than these surfaces that don't have any self-shading or adjacent shading. So that might be a way to inform tuning louver locations. If you were looking for cost-saving measures and you wanted to, say, remove some of the louvers in a location that will have less of an effect on the ETTV and less of an effect on the building energy use and overheating potential. You could take a look at maybe removing the louvers on these two small portions of the building because there's some self-shading of the building going on there. This concludes video tutorial number 5. In the next tutorial, we'll look at HVAC systems in more detail and compare some different HVAC systems.